Hi, I'm Zach with Pinecone, and now I'm going to walk you through how to destroy a deployed AWS reference architecture with Pulumi. On the left here, I've just deployed the entire reference architecture, and on the right side, you're seeing me connected to the central RDS Postgres instance via a jump host. So if you're not familiar, if you come to the repo and take a look at the schematic for the reference architecture, we have intentionally deployed the front-end UI and ECS microservice in a public subnet of the VPC, and you'll notice that the two other microservices, as well as the Postgres database itself, are in a private subnet, and that is intentional to prevent direct access via the internet to the Postgres database. The only things that can access the Postgres database directly are the two microservices running in the backend, so Pelican and Emu. The front end is also able to access it directly due to security group settings, but you cannot just connect to Postgres from your client machine because it's in a private subnet. This is a common pattern with many architectures, but also with ours. We've intentionally created this separation so that the database, the persistence tier is secure. And so in order to access that directly, what you need to do is follow the instructions that exist here in the repository and that are linked from the table of contents here for common tasks. And you'll come to this section explaining how to use a jump host, how to launch it, and how the jump host actually works. And importantly, if you launch a jump host in order to interact with Postgres directly, as I'm doing here, so that you can issue counts or arbitrary SQL, then that jump host will not have been provisioned with Pulumi. And so this is important because what it means is that we're going to have to unwind a couple of things in AWS via ClickOps or the AWS CLI or the API in order to get the reference architecture to a state where we can run a Pulumi destroy and have Pulumi handle all of the actual API calls and the dependencies required in order to tear down the architecture cleanly. So let's now get started unwinding the security group changes that we made in the AWS console. And once that's done, we will commence the Pulumi destroy to tear down the reference architecture. So the first thing to understand is that the database has its own security group. This is the RDS security group. And by default, and as codified in the Pulumi code, this security group only grants access to two security groups. Those are the front-end security group, so the front-end UI that is user-facing that provides the table for semantic search, and then the Pelican security group because the Pelican microservice connects directly to Postgres in order to listen for changed records. In the process of setting up the jump host, which we've done in a previous section of this video, we've also manually added after deployment this additional inbound rule to the security group stating that the security group named Launch Wizard 2, which was used to provision our EC2 jump host, also should have access to this RDS instance. This is what allows me to issue arbitrary SQL here and for the network connectivity to work such that my query goes from my developer's machine to the jump host via SSH, and then from the jump host to the RDS instance, and then the results are streamed back to me. And all of this is, again, explained here if you want to step through it and understand, and there's diagrams, and the docs also explain how to do this manual setup. So we're just going to do this now in reverse. So to start with, we will edit these inbound rules again for the RDS security group. We will delete the rule that we manually added to allow the jump host to have access. What you'll also notice is that now if I were to exit out of this session and then attempt from the jump host to connect again directly to RDS, this command is going to hang forever because there is no longer network connectivity between the machines as required. we can also just take a look and see that, as I mentioned before, the entire architecture has been deployed. We've got the 3 microservices and their separate ECS clusters running. You'll notice that there's been some scale out behavior because the system is currently under load and is processing records. So one of the things that so the first thing that we did is we undid the RDS security group change. There's another thing that we need to do manually in order to prevent the custom VPC that was deployed from hanging forever due to stuck dependencies. You need to come in here, find the jump host or the bastion host that we launched earlier, and then terminate it. And click confirm to terminate. And we'll want to wait until this is fully destroyed, fully terminated, and shut down. Partly because this EC2 instance of this jump host uses elastic networking interfaces, and if we don't tear this down first, and then we attempt to just go through pulumi and do pulumi destroy, the API calls that pulumi might issue in order to tear down the VPC could end up hanging for 10-20 minutes because of just stuck dependencies. So I found that it is far more expedient to come in here, manually delete the bastion host, because again, the bastion host is not seen by pulumi. We launched it out of band, outside of infrastructure as code. And so this is us just unwinding that effort. All right, and then now we can see this instance is gone. Okay, and with that, we can hop back to the terminal. In the same session where we've set all of the environment variables, we'll run pulumi destroy. And if we take a look at what that's going to do, we see that for all of the resources in our stack that were defined as part of the reference architecture, all of the outputs, etc., that they're going to be destroyed. So this looks good. And so you can choose yes. Generally speaking, the teardown process for the reference architecture issued via pulumi is pretty smooth. There are occasionally some resources that can get stuck and that might require some manual deletes. And so we'll sit here and watch it get underway. And in my experience from deploying this and tearing it down repeatedly, the most common resource that's likely to get stuck is the VPC, the custom VPC, due to the same issues I just mentioned. So if you had forgotten to unwind the RDS security group updates, or if you had forgotten to manually terminate the bastion or jump host that you provisioned in order to access the backend resources directly through your own machine, then that can cause the custom VPC to take longer to tear down, because in order for the VPC to be destroyed, each and every dependency, including elastic network interfaces that things like the ECS services and or jump hosts, RDS, etc., might be using, all need to be gone and destroyed. That includes security groups as well. So again, the key point here is that anything that you've done outside of infrastructure as code, outside of pulumi, anything that's not defined in the index.ts TypeScript file, needs to be undone the same way it was done. So you can either use the AWS CLI or you can use the UI in order to back out that change. Once you only have deployed in your account resources that are tracked in the index.ts file, then you're in a good state to run pulumi destroy, and then wait and also make sure that the various resources don't get stuck. So for the case of, front end service, Pelican service, Emu service, as we saw, the reference architecture I just had deployed and I was looking at actually was under load because I was testing it, so there was records flying through it. This pulumi destroy essentially tells the ECS APIs to force delete those services, including dropping any of the ECS containers that were running for it. So that goes pretty smoothly. All right, and once the RDS database is deleted, we move on to the RDS security group. we start deleting some of the actual services. So the emu service still needed to go. The application load balancer, various security groups for the microservices, and now we are getting into the dependencies of the custom VPC that we've provisioned for the ref arc. So working backwards, we're going to first delete the routes, the route table associations, the NAT gateways, and then we'll move on to the VPC itself. The NAT gateways take several minutes each as well, similar to RDS instances. And with the NAT gateways out of the way, then we start deleting some subnets. We are deleting the SQSQs. We are releasing elastic IP addresses that we had leased, clearing out all of the dependencies that go into the custom VPC. And now with the dependency out of the way, we are deleting the custom VPC itself. And this is where we would have ended up hanging for a long time or getting stuck sort of silently if we had not unwound the jump host changes that we had made out of band of pulumi. So just do that first if you're planning to destroy the reference architecture, because it will ensure a relatively smooth teardown. So at this point, if pulumi is already attempting to delete the VPC, sometimes I'll come in here if I'm feeling impatient, find the VPC myself and attempt to delete it manually. And for various reasons, that can be a little bit faster. And then pulumi tends to pick up that change relatively quickly once it's done. So as long as you don't have any dependencies because they've been cleaned out, that's sort of a way to get there a little bit quicker. And then voila, we are done. And the same number of resources that we initially stood up when we applied the ref arc have now been deleted, and the duration is exactly a minute off of what it typically takes to deploy the ref arc. So it tends to take about 17.5 minutes to come up once you've done the setting of the environment variables as necessary in the current iteration of the ref arc, and tends to take about as much time to be deleted, assuming there's no snags that you encounter. All right, that is how we destroy the ref arc using pulumi.